Ladies and gentlemen, welcome to my channel. If you haven't subscribed, please make sure that you hit the subscribe button and press the notification button. And in so doing, you will be supporting us. In this lesson, we are going to focus on esterification. We're going to teach esterification process. We're also going to show you the organic chemicals that need to react in order for an ester to be formed, and that will be the esterification process. Ladies and gentlemen, we may start. Esterification. Esterification, it is the process of making an ester. Esterification is a process of making an ester. A process of making an ester. This esterification process is a process that we use in the laboratory. So we use the esterification. So before we go straight to esterification, let us talk about esters in general. The esters are responsible for good odor, responsible for good smell, good odor in the food industry. In the food industry, you know that in the food industry you will find that a certain type of food, it smells very good, and that is a result of a chemical reaction that is made, and then it results in that very good smell. So that very good smell, it is a result of the ester through the process of esterification. In the food industries, esters are not only used in the food industry only. You know, the the sprays, roll on, roll on. We buy roll on, we buy Nivea, we buy status, blue eyes, those things that smell very nice. Nice fragrance is because of esters. So esters are responsible for good smells. You know that some flowers, they smell very nice. That is because of ester. It is a reaction which is occurring naturally in flowers, and then we get to produce very good smell. I mean, we get to find flowers that smell nice. It's a result of natural reactions. Ester. You know, we use esters for many things. You know, these days there are condoms. The condoms that we buy, you find that you want the one of a banana, you want the one of different things. It is a result of esters. I'm using things which we don't love very much, but I know you will not forget. In case they ask you, I will just basically say something that I know that you will not forget as a young person. So it is used in many different things. In what do you call this? The smoker pipe, the smoker pipe whereby you buy a coal. I mean, you buy a coal and use it to smoke, and there is a big a smoke. You call it hubly. I know you love hubblies. So whenever I talk about the hubblies, I talk about the condoms. I know you will not forget those smells that you find in the things that I mentioned. It is the result of esters. So ladies and gentlemen, that's how we introduce our ester. So we need to talk more of chemistry other than to be general when we talk about esters. Now we're on it. Ziakala again. Let's go. Okay. Ladies and gentlemen, we are starting esters. Esters. We are going to start from the suffix of esters. the suffix of esters. Suffix of ester is owate. Owate. O-A-T-E. The suffix of esters is owate. So each and every ester at the end, you will hear the word owate. You will hear the word owate. Those are esters. The ending name of each and every ester is owate. As you know that the suffix, this is the ending word. Then let us go straight to the esterification process, because I've never seen an exam without the esterification process. I think it's just as one of those processes that are not complicated, but some of our kids, they fail to understand. But I'm giving you an opportunity through these online classes for you to understand the process of esterification. The question is, what are the chemicals that we need to mix in order for us to form an ester? What are the that need to be mixed in order for an ester to be formed? I've posted an experiment whereby we were doing an esterification process in the lab. If you didn't check that experiment, please, you'll find it in the comment. I will paste the link in the comment section. So now, in order for us to form an ester by the process called esterification, we are going to react an alcohol. An alcohol, we react it with carboxylic acid. When we react an alcohol and carboxylic acid, we are going to form what? We are going to form an ester and water. Maybe for me to use the space, let me write it like this. We're going to have alcohol. Alcohol, we mix it with carboxylic acid. Then I draw an arrow. The arrow shows that it is a chemical reaction, of course, which is not reversible. Then we create an ester plus water. So please remember that the process of esterification, it will always produce an ester and water. So whenever you come across a question that says using chemical structures, chemical formula, show the reaction of alcohol and carboxylic acid to form an ester, you need to know that when alcohol reacts with carboxylic acid, we are going to form an ester, but we're also going to form water. Water is always going to be one of the byproducts of the esterification process. So I know that in most of the time we come across situations where us as learners, we do not understand what is a structural formula, because a question will say use structural formula to show the reaction. So when they talk about structural formula to show the reaction, you end up not knowing what to do. Ladies and gentlemen, when we talk about the structural formula, we are talking about all those structures, the drawings that you have been making in this whole topic of organic chemistry. Let me give you an example. I want us to demonstrate an esterification process using ethanol. I'm going to use ethanol and ethanoic acid. I'm going to use ethanol and ethanoic acid. So when they say use structural formula, they want you to make use of drawing of structures. That's what they mean. Do not be confused by the word formula. Those drawings, all the drawings of carbon, hydrogen, we call them structural formula. So I'm going to react ethanol ethanol plus ethanoic acid. Ethanoic acid. We want to see the type of ester that is going to be formed. Ethanol. Ethanol is an alcohol which has 2 carbon. Then let us have the structural formula. This is the structural formula, and we know that an alcohol has got OH. We know that an alcohol has got OH, which is the hydroxyl group. That is the functional group that we call hydroxyl group. The functional group that we find in alcohols, it is called hydroxyl group. Are we together? Are we together? So this is the structural formula of alcohol. This is the structural formula of alcohol. Then we add ethanoic acid. We know that an acid has got a functional group that we call carboxyl group, which is double bond O and OH. Then I'm going to demonstrate that to you. We've got OH, which is bonded to a carbon, which is bonded to a double bond O. Then we have this. Remember that carbon can only create 4 bonds. Carbon can only create 4 bonds. So this carbon created only for 1, 2, 3, 4. That's why there is no hydrogen here, because carbon can only create 4 bonds because it has got 4 valency electrons. So it is in short of only 4 electrons for its outer shell of bit to be filled. So it can only create 4 bonds. So whenever you make a structural formula, you draw a structural formula with many bonds into one carbon, just know that you are wrong, because carbon is going to have only 4 bonds. That's why I have 4. 1, 2, 3, 4. Can you see that? So that is what is happening. So ladies and gentlemen, let me demonstrate to you the esterification process using this. Here is our esterification process. We are reacting ethanol and ethanoic acid. Then we need to draw an arrow. I no longer have space. I'm going to complete my arrow here. What we are doing is like when we react A plus B. We react A plus B and it forms AB. So we are just using structural formula to do the same thing. A is like we are reacting alcohol and we react carboxylic acid to form an ester. We must not forget that another byproduct of esterification is what? Is water. So we must not forget that. So this is what is happening. It's just that I do not have enough space for me to draw everything in one place. Rather, because I know that kids will always take the negative and they go and draw this. Let me erase this and make a smaller drawing so that you can see. Everything must be represented in one page. Let me make a smaller drawing like this. It means I'm going to have carbon. Not that I'm just doing the same thing. I just want to use a smaller space. We have OH. Then that's what we have. That's what we have. Can you see? I have reacted what? Ethanol and ethanoic acid. Then to form an ester. So this process is called esterification process. So what is going to happen? What is going to happen? This is what is going to happen. The OH from the alcohol is going to be donated. It's going to move out rather. It is going to move out. It's going to detach. Then one hydrogen from the carboxylic acid is also going to move out. You understand? So it means that OH from the alcohol is going to move out, and one hydrogen from the carboxylic acid is going to move out. And then what's going to happen? In a way of demonstration, it's like the OH is going to move out. Notice what we will have. You see, I've removed the OH. Ne? I've removed OH. It is intentional, ladies and gentlemen, but you must not do it. I'm trying to demonstrate and teach you. I will draw them again. Then here, you remove H. You see, we'll be left with what? With this oxygen, which is alone, and this side, we no longer have an OH and a hydroxyl group. Can you see? Then what do? We make these two to come together. When these two come together, it will mean that we now have an ester. Remember that the OH that moved here plus H, it is going to give us H2, 2H and 1O, you see, and that is water. That's why we say that the byproduct of the esterification process is ester and water. So that's what happened. So ladies and gentlemen, what I did, it was for the sake of making a demonstration for you. You must not do it when you write in class. OH must remain here, and the OH for this side must remain there. So I did what I did to show you and demonstrate to you. But notice that alcohol is going to lose its hydroxyl group, its OH, and the carboxylic acid is going to lose its hydrogen. Then the OH from the alcohol and the hydrogen from the carboxylic acid are going to come together to form H2O. H2O, which is water. Are we together? So then you make sure that after removing OH this side and you remove H this side, you make the two to come together, then you'll have a carboxylic acid. So what is the product? You see here, I just drew an arrow to show you that this is a reaction. So it means I'm going to have two carbon this side from the alcohol side, then I combine them with one oxygen. Why is it one oxygen? Remember, I said this hydrogen moved and this OH moved. So it means I'm going to combine this. You see this? This is an ester. You see what? This is just a demonstration, ladies and gentlemen. You must not do it on your left side. It must happen on the right side. So let me make my OH to remain there and the OH to remain this side. So then I'm going to have this. So that's what I have. You see? That's what I have. So this is my what? Is my ester. I formed an ester. So now I need to show you how we give the IUPAC name of an ester. I want to show you how we give an IUPAC name of an ester. Do you see the type of an ester that we formed? There it is. We just remove OH from the alcohol and the H from the carboxylic acid. Then we push everything together. Then that's what we formed. You can see that the oxygen is in line with the carbons. So that is very important for what I want to demonstrate to you. Are we together? We have 2, and this side we have 2. 1, 2, 3, 4. Then we are fine. We are fine. Are we together? Okay. So this is the ester that we formed. But remember that the esterification process, it does not only form an ester, it is also going to form a water molecule. Remember we removed, I said here that the OH and the H from the carboxylic acid are going to move out, right? So it means we are going to add, I was supposed to write here, you can see this is the end of the board, I no longer have the space. So you are supposed, or let me, I won't do it. We're going to add the plus H2O, which is O and H, just like this. Isn't it the question wanted us to use structural formula to represent? So this addition sign is after this, guys. Please don't write it at the bottom. It's just that I don't have space. You understand? So that's what happened. We form an ester and water. as the byproduct of the esterification process is what? Is ester and water. Or rather, let me make this to be small so that I can squeeze that structure of the structure of water. Because I know that you as our kids, you always choose to do the negative. Matuke, you love doing the negative. You love doing the negative. So this is what we're going to have plus O. Yes, now we have demonstrated it better. Can you see that when we react this alcohol and this carboxylic acid, they are both F. They've got two carbon, ethanol and ethanoic acid. OH from the water, from the alcohol, OH from the alcohol is going to be donated, and the hydrogen from the carboxylic acid is going to be donated. Then they combine and form water, which is H2O. That's why at the end we've got H2O and an ester. I hope you can see that. Interesting. So now I want to show you how to give the IUPAC name of an ester. So this is a reaction using structural formula. I think I will repeat the same process again using other chemicals. But before I do that, let me show you how to give the IUPAC name of an ester. Let me draw the very same thing so that we can give its IUPAC name while it is standing alone. I want to show you how we give an IUPAC name of an ester now. We are done with the reaction part. I will repeat the same process using other chemicals. So now I want to show you how we give an IUPAC name of an ester. Here we have an ester. How do we see that this is an ester? An ester have got a carbonyl group and an oxygen. A carbonyl group and an additional oxygen. And you notice that this is a special functional group that we'll find only in esters, whereby oxygen is in line with the carbon plus a carbonyl group. Remember, a carbonyl group, it's what? Double bond O. A carbonyl group, it is double bond O. So how do we give the functional group of an ester? This is how we do it. Ladies and gentlemen, what I'm trying to show you, you must never do it and submit to your teachers. You do it for yourself, then you write the correct answer. Us as teachers, we must not even see what you did. Ourselves as teachers, we must not even see what you did. So this is what you do. You draw a line and cut the ester into two parts. You draw a line and cut the ester into two parts. And the line must cut through the oxygen. So this oxygen, which is in line, in the same line as the carbon, it is the one which is used as a symmetry. It's used as a symmetry. It is used as the axis. You need to cut the ester where there is what? The oxygen that is in line with the carbon. So you cut it. So I can write somewhere here. Cut the ester at the oxygen. Cut the ester at the oxygen that is in line with carbons. Do you see what you must do? If you want to give the IUPAC name, the first thing you cut the oxygen. You cut the oxygen that is in line with the carbons, right? It means you cut your esters into two equal halves. But I can't say equal half. This one is two equal half, but you'll find that you use an alcohol with a longer carbon chain and a carboxylic acid with a shorter carbon chain. It won't be equal half. We can just say symmetry. The line of symmetry for the ester, it is going to be the what? The oxygen, which is in the same line as the carbon. This oxygen. Are we together? So now You have divided this ester into two parts. I must not say two equal half, although this one is two equal half, but I must not say that because I'm just giving you general information that will work for all the esters. So now, since you have divided into two, how do you notice which part is a carboxylic acid and which one is an alcohol? Because sometimes in the exam, you are going to come across a question which will ask you, they give you an ester like this and they say, tell us the type of an alcohol that was used and the type of a carboxylic acid that was used, right? So how do you get to know that? Let me write, right? The part with double bond oxygen. The part with double bond oxygen is a carboxylic acid. Is a carboxylic acid. So the part which have got double bond oxygen is a double bond. The part with double bond oxygen is a carboxylic acid. What does that mean? It means the remaining part is an alcohol. By doing this, you'll never miss. You will even know the type of an alcohol and a carboxylic acid that was used. Let us look at this one. I'm cutting it at the symmetry, and I told you that the symmetry is oxygen. Notice that the things that I'm saying, they are not true in chemistry and in science. It's a way to try to teach you so that you can understand what you need to do, right? This is not symmetry. It's just my own creation so that I can teach my kids so that they understand as I'm teaching you. You will not make a mistake by giving the IUPAC name of any ester using what I told you. Remember, I said the first thing you cut the ester in the line of symmetry, which is the oxygen that is between the carbons, right? Then you will have two parts. Then the part which have got, as I was saying, that you cut it into two equal half in the symmetry. The symmetry is there where there is oxygen between the carbon. So now I've cut it into equal halves. So how do we know that which part between the two is the how do you know between the two which one is carboxylic acid, which one is an alcohol? I wrote it here, right? I said that the part which have got the carboxylic acid is the part which will have the double bond oxygen, and the other part is going to be the what? The alcohol. So now let us give the IUPAC name of this one. Now, this is how you do it. Take the alcohol as the branch. You take the alcohol part as the branch, and carboxylic acid as a carbon skeleton. You take the carboxylic acid as the carbon skeleton, then you will be able to give the IUPAC name. It means you can see we have two parts. I've divided into two halves. Then this part, can you see it? It is the carboxylic acid. This one is the what? It is the alcohol. Then you take the alcohol part as a branch. Then you take the carboxylic acid side as the longest carbon chain, right? So it means that the IUPAC name for this one, it means you have got a branch with how many carbon? With 2 carbon. Are we together? So let us give the IUPAC name for this one. The IUPAC name for this one is easy. I said we take the alcohol part as a branch, right? Remember that each and every branch, the suffix of each and every branch is YL. YL. How many carbon do we have in this branch? We've got 2. 2, what does 2 mean? Is F. So it means the name of this one is going to become ethyl. Remember, according to everything that we have learned, this is not a branch. What I'm just saying now, it's a method how you can give a name without making a mistake, right? You take the alcohol part as a branch, and you take the carboxylic acid side as the longest carbon chain. So it means this one is the longest carbon chain. How many carbon? 2 carbon. So it means the IUPAC name of this ester is going to be ethyl. No, wait. Remember that the suffix of all these things of esters is OH. So that's how we do it. I hope you saw how we get to do these things.